Every morning it rises without fail, the steady, dependable sun. It feels eternal. It is not. Our star is slowly, quietly dying, and one day it will destroy the Earth entirely. Tonight we trace the sun's future, moment by moment, from the gentle warmth you feel now, to the violent, beautiful death that will one day scorch our planet from the sky. The sun is a star, a colossal sphere of glowing gas, 109 times wider than the Earth. At its heart, under crushing pressure, hydrogen atoms are fused into helium, releasing the energy that lights our days and makes life possible. It has been doing this for 4.5 billion years. Every single second, the sun converts around 600 million tons of hydrogen into helium and pours the released energy out into space as light and heat. It is a controlled, self-sustaining explosion, 4.5 billion years old and counting. But its fuel, though vast, is not infinite. The sun was not always here. 5 billion years ago, it was born from a vast, collapsing cloud of gas and dust, itself the scattered ash of older stars that had died before it. To understand how the sun will end, it helps to remember that our star, too, once had a beginning, and the sun is not a simple ball of fire. Beneath its blazing surface lie hidden layers. A core hotter than 15 million degrees, where the fusion burns. A vast radiative zone, where a single particle of light can struggle for tens of thousands of years just to escape. And a churning outer zone that boils that heat up to the surface. The good news is that the sun is only middle-aged. It has enough hydrogen to keep shining, much as it does now, for roughly another 5 billion years. So the sun will not simply switch off tomorrow. Its death is slow, and it unfolds in stages, each one stranger and more violent than the last. But here is the first surprise, and it is a grim one. The Earth is in serious trouble long before the sun actually dies, because as the sun ages, it is slowly, steadily growing brighter. It is about 30% brighter today than when it was born, and it is not going to stop. In around 1 billion years, the sun will be bright enough to push the Earth past a fatal threshold. The oceans will begin to boil away. Water vapor, a powerful greenhouse gas, will flood the atmosphere and trap even more heat, running away out of control. Earth will become a scorched, sterile world long before the sun's true death. So, the end of life on Earth and the death of the sun are two separate tragedies. Our planet may become uninhabitable within 1 billion years. The sun itself carries on for billions more. But eventually, deep in its core, the moment finally arrives. The hydrogen fuel begins to run out. With the core's hydrogen exhausted, fusion there falters, and the core, no longer pushing outward, begins to collapse under its own immense gravity. As it shrinks, it heats up dramatically, and that intense new heat ignites a shell of hydrogen around the core, burning fiercely. The sun is about to transform. The burning shell pours out far more energy than before, and the outer layers of the sun respond by swelling enormously. Over a few 100 million years, the sun bloats outward, its surface cooling to a deep, angry red. Our steady yellow star becomes a monster, a red giant. As a red giant, the sun will swell to more than 100 times its current size. First, it will swallow the innermost planet, Mercury. Then it will engulf Venus. And then its glowing surface will come for the Earth. Our world will be scorched, then quite possibly swallowed whole, its remains vaporized inside the star. Even if the Earth is not fully engulfed, it will be a blackened, molten cinder, orbiting inside the outer atmosphere of a dying star. Every ocean, every mountain, every trace that we were ever here erased. The sky, for whatever might watch, would be filled entirely by the vast red face of the sun. There is a strange, fleeting mercy hidden in the sun's swelling. As it grows, the narrow zone where liquid water can exist marches outward into the frozen edges of the solar system. For a few 100 million years, the distant icy moons of Jupiter and Saturn may thaw and enjoy a brief, unexpected spring at the very same time the inner worlds burn. It is worth noting how gentle the sun's death truly is. Had our star been born just 8 times heavier, its ending would have been catastrophic, a supernova, briefly outshining 100 billion stars, forging the heaviest elements in its fury. Our sun is far too small for such violence. Its farewell is quieter, but no less final. But the red giant is not the end. Deep inside, the collapsing core keeps heating until it crosses a new threshold. Suddenly, the helium that fusion has been building up all this time ignites in a runaway flash. In a matter of minutes, the core unleashes a burst of energy rivaling an entire galaxy. For a while, the sun steadies again, now fusing helium into carbon and oxygen in its core. But helium is a poorer, faster-burning fuel than hydrogen. This final chapter lasts only around 100 million years, a mere blink compared to the sun's long and stable youth. When the helium too runs out, the sun has no way left to hold itself up. It is not massive enough to fuse carbon, and not massive enough to explode as a supernova. Instead, its fate is gentler, and in its own way, one of the most beautiful sights in all the cosmos. Growing unstable, the sun begins to pulse, and with each pulse it gently sheds its vast outer layers into space. Great glowing shells of gas drift outward, lit from within by the exposed, blazing core. This luminous, expanding cloud is called, somewhat misleadingly, a planetary nebula. These nebulae are among the most gorgeous objects in the universe. Rings and hourglasses and butterflies of glowing gas, thousands of them scattered across our galaxy, each one the beautiful death, shroud of a star much like our sun. The helix, the ring, the cat's eye. One day, our sun will paint one of its own. At the center of that fading nebula, one thing remains: the sun's dead core, exposed at last. A sphere of carbon and oxygen about the size of the Earth, but containing half the mass of the entire sun, crushed to unimaginable density. A single spoonful of it would weigh several tons. This is a white dwarf. The white dwarf is the true corpse of the sun. No longer fusing anything, it simply glows from its leftover heat, an ember pulled from a fire that burned for 10 billion years. And it will do something almost unimaginable. It will cool and fade for a very, very long time. A white dwarf cools so slowly that it takes many trillions of years to fade completely, far longer than the current age of the universe. Only after all that time will it finally darken into a cold, dead sphere of crystallized carbon, a so-called black dwarf. In truth, the universe is not yet old enough for a single one to exist, and so, in the end, the great glowing gas cloud drifts away and dissipates into the galaxy, carrying carbon and oxygen forged in the sun's final centuries. That enriched gas will one day gather into new stars and new planets. The sun's death will help seed the births to come. It is worth pausing on that. The atoms in your body, the carbon in your cells, the oxygen you are breathing right now, were forged inside earlier stars that died exactly this way, long before the sun was born. We are, quite literally, the recycled ash of dead stars. And one day, our sun will pay that gift forward. Now, none of this means humanity is doomed to burn with the earth. We have 1 billion years, at least, before our planet becomes unlivable. That is an almost unimaginable stretch of time, more than enough, perhaps, to become a species that lives among many stars and no longer depends on this one. Our distant descendants, if there are any, may watch the sun's death from a safe and distant world. They may see our star swell red, swallow the earth, and blossom into a glowing nebula. They may know it as the place their species began, a small blue world long since gone. The sun that warms your face this morning is not eternal, but it is faithful, and it has billions of good years left to give. It was born from the death of older stars, and it will die to give birth to new ones. In the long story of the cosmos, our sun is a single, brilliant chapter, and we are lucky beyond measure to be here to read it. Thank you for facing the death of our star with us tonight. If it made this ordinary morning feel a little more precious, then consider subscribing and join us for the next journey out into the dark. Until then, keep looking up and stay spaced out.